So yeah, and actually, yeah, this is quite. You save a lot of time like this way, and don't lose any information. Now you can load the shapefile, and you have to set some breaks to map, right? The data. I mean, in this case, I'm mapping homicide rates, so I'm gonna specify some breaks from 0 to 5, to 6 to 7, or whatever. So what I'm doing here is precisely using the read shapefile poly function to load this municipios shapefile, which is going to be saved as a Mexico object. And you type this, you can see the headers, all the headers of the columns, right? And you will realize that all the new attributes were merged in. And here I'm just selecting the colors that I'm going to use to plot the map. It could be red, blue, etc. And then we need to set breaks in the data in order that we have like a representative color palette, right? So
by setting breaks, you mean like coarsening your ceilings variable?
Exactly, exactly. And you can use the class intervals function, specifying that you want to use, in this case, the homicides 4 variable from the Mexico data. I'm going to have 6 breaks, and the style I'm going to use is fixed, which is basically I'm going to fix those breaks. There is also a style standard deviation, so it's going to create 6 different groups based on the standard deviations or quantiles, or there are many different ways, so different styles of creating these breaks. Since this data, given the characteristics of this data, for me it was convenient just to create these breaks from 0 to 5, 10, 15, 20, and there are municipalities in Mexico with 600 homicides per 100,000 people. And I'm going to store that as breaks. Now, if you want to have a sense of how your map will look like or whether your breaks make sense, you may want to plot the distribution of the data and the colors associated to the data. And to do that, it's simply you use the plot function for breaks and specify the palette equal colors. And you can see here the distribution. So basically, you have most of the observations with less than 20 homicides per 100,000 people, but we have some crazy cases in which the homicide rate goes up to 600. If the distribution of your data is it's prettier, then the graph looks much nicer. But here you can see it really much, but still it's useful to have a sense of how the distribution looks according to the colors that you assign for each group. So here we plot the map. So from this point, we are only interested in the break values, right? So we can extract the values from the breaks object that we created. So the breaks associated to the breaks values will be called breaks. And then we can just plot the map using the Mexico data, specify the colors and the interval using the breaks, and we get this map.
What are the white ones?
Sorry?
What are the white ones?
The white ones?
Yeah, you have some white in Baja, California Sur.
Oh, it's actually very pale red.
Okay.
Yeah. But it's like a very low homicide rate.
A better pal.
Yeah. So it got really crazy here. This is for the last presidential administration, and it's just crazy.
Omar, let's assume you want to do the same but at the state level. You want to do it from the shapefile?
You need a shapefile at the state level. So, yeah, that's important. I'm using a shapefile at the municipality level for Mexico. If I was using a state level, I can overlay a state level shapefile as well. But if you want to plot the data at state level, you need to put it in that order.
Is there an aggregate function?
You have to aggregate it the way you collapse it, any data
Okay.
in either R or Stata. So, but not an aggregate function to aggregate a shapefile, no. Then you have several options. If you type box after creating your plot, it's gonna create this frame around the map. You can put the title this way, and this takes less than 1 second. Here I'm just introducing this the north arrow, which is kind of useless, and the legend. So the legend is important, right? So you can add the legend just using the legend function, and specify that you want to fill it with the colors that you assigned for the values, and it will automatically generate a legend saying under 5, from 5 to 10, 10 to 15. So
You cannot decide where it ends up in the graph.
Oh, yeah, I'm specifying the location of the legend.
Right, sorry.
So in here I'm saying it's gonna be X is the latitude, and then the Y is the longitude. So it's gonna place it there.
These things look like any plot parameters.
Huh?
These look like any plot parameters.
Yeah, exactly. Yeah. Like any plot parameters. In this case, using the coordinates, right? Just in decimal degrees. So, yeah. So this map, doesn't take much time, and especially for the legends, and you can customize everything, change the location of everything, and change the width of the outlines, everything. Okay, so now I'll show how to do some also like basic maps with ggplot. So you will need again the map tools library, the ggplot tool, and this library, which is just basically I haven't used it I have only used it for this, which is to extract the data frame from the shapefile so that it can be read by ggplot. So again, set the directory, load shapefile. I'm using this example from the R bloggers where they plot the participation in sports activity by each borough in London. The reason is that I try to create my Mexico maps in ggplot, but it was taking forever. So that's one thing. The other maps are super fast. This one take some time, but look a bit nicer probably. But in any case, so I'm using this function again to read the shapefile, and I'm gonna call this sport. You type name sport, and you can see the headers. So the nice thing about using ggplot is that you can also explore the different ways the data that you will be actually mapping before creating the map. So you have to plot it because this way you will indicate where you want the input data to come from. In this case, you want to use the attribute table of the shapefile, which is going to be the data associated to the sport object that we created, and what parts of the data frame you want to use. So in this case, we are using two variables, the participation in sports activities and the 2001 population. So you cannot see the graph very well, actually, but this looks like a regular ggplot, and here on the y-axis you have the population, and in the x you have the participation in sports. So this one looks a little better. In here, I'm just changing the size of the dots using the population of each borough. The color intensity is capturing the participation in sports. So in here you already get a sense of how your data is distributed, and it looks sort of nice. You could also add the names. Here are too tiny, but you can add the names for each observation that you are plotting. So you don't have to run all these plots, but you have to run at least one, because that way you will be specifying, you will tell in Gplot that you will be choosing those data frames from that shapefile and the specific attributes that you are plotting. Okay, so now this is the tricky thing. To get the shapefiles into a format that can be plotted or mapped, we have to use this 45 function. And so basically, from what I understand, what you are doing is that for some reason, Gplot reads the coordinates in a different way. So they are stored in one column, I think, in the shapefile, and then you have to split them and obtain the data frame, and then merge again the attributes to the data. So you just do that using this 45 function for the sport object, and the region you will specify that it's the identifier of the polygons. In this case, the variable is called onLabel. And you are gonna be saving this as sport geom. And then we will merge. So when you do this, you lose all the attributes of the data. So it's just basically getting the shapefile into a data frame. And then you have to merge the data attributes from the sport object with the new object created using the coordinates which are going to be basically the identifier and the ID, the identifier and the identifier or the name of the polygons, and save the same sport geom object. Okay, so this is the way it looks. So you're using the ggplot function the same way you use it for creating any graph. You will be using here the sport geom and the latitude and longitude, and the group variable equal to group this is just basically indicating this is a variable that was created when you executed the 45 function, and it's going to be to associate the new shapefile to the data frame. You will fill the data with the participation in sports activities. The geom polygon specifies to ggplot that you want this to be like a polygon figure. And then you can add the labels in here, like the eastern coordinates, northern coordinates, and the label for the field values, which is here, is the percentage of sports participation, and the title of the map. And if you want to customize this, for example, you can use this scale field gradient option to indicate ggplot that you want this to be the lower values to be plotted in a scale that ranges from white to black, black being the higher values. Those are like a bit more complicated, and actually I just started playing around with them. I think I've seen like very, very, very good maps using Gplot, and potentially it's something like useful. Now, I would like to show you how to do some zonal statistics with a different software. I think this is like a very, very useful because, for example, if you are computing the levels of precipitation between 1960 and 1990 for each county in the US, you need to do some work like this. I started doing this in R, but I always had some problem, and I just realized that this software is very straightforward and doesn't take much time. This is also like computational intensive, depending on the resolution of your data. But with this software, I've been very satisfied. So I'll show you very quickly how to implement that. Okay, so this is how it looks like. Quantum GIS is an open source software. I don't know whether it's available for Windows, but probably it is. It's similar to ArcGIS in the way that you store it saves your layers here, and you can do a bunch of stuff just clicking on the icons. But it also allows you to interact with R or with Python if you want to write some script. The basic thing that I'm going to show you now is how to construct, for the case of Mexico, municipality level measures of terrain suitability for growing corn, which is something I've been working on recently. And so the first step is I went to the FAO website, and they have these geoecological zones of the world, or I don't know what. So they are basically raster files with measures of precipitation, of terrain ruggedness, of crop suitability. And I downloaded the corn suitability for the whole world. And this is in a raster file. A raster file is basically it's a picture composed by a bunch of pixels, and each pixel has a color, and this color is associated with some value, and you can do a lot of zonal statistics using these kind of raster files. This here, the resolution is like, I think it's like 10 kilometers by 10 kilometers, or 1 kilometer by 1 kilometer. I don't remember, but something very, very, very precise. So here you have the option of add raster layer. I have my raster file here, which is in TIF format. As I said, it's just like an image, a picture. I already loaded, so I'm just going to show you how it looks like. So this is the raster file. So these are measures of terrain suitability for growing corn throughout the world. And this is already collapsed, averaging annual measures from 1960 to 1990. Now, in addition to that, I need my administrative boundaries layer, which is a shapefile. So you just go here to add vector layer. Vector layers are all kind of shapefiles, either lines, points, or polygons. And again, you just browse it. I already have it here, and load it. Now, if you want to see closer, just zoom to the layer extent, and you see the map, right? So all these are municipalities in Mexico, and what I'm gonna do is, if you zoom in even more, you can see the actual pixels, right? So this is squares. So what I'm gonna do is that for each polygon, I'm gonna compute the average based on the values assigned to each pixel. So to do that, you need first to convert your raster file into a shape file, into a, in this case, a vector layer or a polygon layer. So you just go to raster, conversion, polygonize, and in here you select where you want to store the file. You write the name of the file and the location. This is the variable of the relevant variable for me, which is measuring the suitability for growing corn. This mask is just relating to the actual, if you have several raster files loaded, you will have 20, so you just want to make sure that you are using the correct one. And here it gives you the option to load the polygonized version of the raster file after finishing. I'm not going to run it now because it takes some time, but it's actually much faster than in R as far as I can tell. So how it looks like? So it looks something like this. So the only thing that I did is to convert the raster file into polygons. So, and these polygons have the values of it's a shapefile with an attribute table. So I have the values for each.
So what happens to the colors? I was expecting each municipality to have the same crop color. But
To have the same color? No.
so are you computing the average of crop suitability at the municipality
Yeah.
level, and you're putting the two maps together, one on top of the other? So I was expecting each municipality to have the same color, the
Oh.
color from the crop map.
Oh no! Because what I'm doing here is just converting the data, the raster file into tiny polygons.
Okay.
But
That have the same shape of the municipality.
no, not yet.
Oh, okay.
Then you have to.
This is still just two separate maps that you're showing
Okay.
these things.
Yeah. So I have it. Actually, this is for the whole world. I mean, I'm covering the U.S. and.
Okay.
But for example, this is, if you go to the polygonized version, you have an attribute table in here. So you have the values for each pixel, and you don't have that when in your raster file. You don't have an attribute table. And then what I'm gonna do is just to intersect these two shape files. I have the polygonized version of the crop suitability data, and I have the shapefile of Mexico. So I'm gonna use the corn data as the input data, and I'm gonna overlay